Hello! In this video, we will show how to perform closed-loop testing with ANSYS Simplorer and SCADE family tools. Systems are everywhere. A car, for example, is composed of many components interacting together with software ECUs in a physical environment. This system or subsystem can be modeled by each of its components, whether it's mechanical, fluid, semiconductor, or software. Behavior of the whole system can be simulated in order to provide useful information to designers. It saves a lot of time by anticipating at the very beginning most of the issues that were previously encountered after integration of all pieces. The ANSYS SCADE product family is a comprehensive, industry-proven solution for developing mission-critical systems and software, supporting the entire development workflow from requirements analysis and design through verification, implementation, and deployment. Simplorer is a tool for modeling physics and enabling closed-loop testing, thus helping product development teams to verify and optimize performance of their control software. With flexible modeling capabilities and tight integrations with ANSYS solutions for 3D multi-physics simulation and ANSYS SCADE products for embedded software design, Simplorer provides broad support for assembling system-level physical models and helping product development organizations connect conceptual design, detailed analysis, and system verification. This video demonstrates an automotive cruise control system on which we will perform software closed-loop testing using digital environment to better and sooner tune control laws. The vehicle dynamics consist of an engine model, simple transmission and drivetrain, aerodynamic drag, all modeled using Simplorer components. An additional electrical subsystem models the charging and discharging behavior or a battery connected to an alternator and electrical loads. The cruise control algorithm is implemented with SCADE Suite and regulates vehicle speed at the desired cruising speed. A rapid prototyper interactive control panel drives the simulation and provides behavior monitoring information. The available output torque is determined by engine torque map and includes basic inertias and damping effects. This is a simplified model of transmission ratio and final drive ratio. It includes vehicle mass and half-shaft inertia. This is an ideal wheel model with no slip that converts rotation into transmission. The electrical subsystem is a dynamic alternator model with inertia and damping. It's a 12-volt battery with wire models and constant power loads. The cruise control model is implemented in ANSYS SCADE Suite and imported into Simplorer as an FMU. The interactive panel sets and monitors the cruise control system interactively. It's created with SCADE Rapid Prototyper. We will show in 3 steps how easily you can perform closed-loop testing. First, we will exercise the software component developed in SCADE in its physical environment in order to detect problems. Then, in order to debug the issues raised, we will debug the software model in co-simulation with its environment. Finally, when the software behavior will be correct and its test case defined, we will show how to measure test case coverage on SCADE model. Let's start with this first step. This is the Simplorer graphical interface, and we will first integrate the software component. In the SCADE Suite environment, we will generate an FMU from the SCADE model. We define the rate of the execution of the software model and the setting for FMU generation. The FMU will embed the code automatically generated out of the SCADE model. Then, coming back to Simplorer, we will add the FMU. Then, start the simulation here. We use the interactive controls provided by SCADE Test Rapid Prototyper to accelerate the vehicle and interact with the cruise control we are testing. We want to see the results of the simulation while we interact with it. The objective is to be able to detect its potential incorrect behavior. From the results, we can analyze what is wrong in our control model. Now, in the second step, we'll see how easily we can debug the software part while running in its environment. Once again, we will come back to SCADE Suite to generate an FMU using the Enable White Box option. This option is used to launch SCADE Suite Simulator in slave mode, driven by Simplorer execution. In Simplorer, we import the generated FMU, and we will restart the simulation. Now, In addition to the control panel, the SCADE Suite simulator is launched. We start the SCADE Suite simulator and play with the interactive controls. We can reproduce the software behavior we want to debug and see states and values of the models while monitoring vehicle speed. The states displayed in purple are the active states, and we can observe all values of computed variables. That way we can understand what's wrong in the model. Now, in this last step, once software behavior is correct and test cases defined, we will show how model coverage can be computed during closed-loop testing. In SCADE Suite, we will use the capability to record a scenario during co-simulation. We specify here the path of the scenario that will be generated. During simulation, SCADE Suite will automatically record a scenario while exercising the software. We will generate an FMU. In Simplorer, we import the generated FMU and start the simulation and perform the software testing procedure with the SCADE Test Rapid Prototyper. We can add a variable plotting area to observe a given value evolution. During execution, a SCADE test scenario will be recorded to capture all events at software interface. Finally, this scenario can be loaded into SCADE Test so that we can measure the model coverage. This is the automatically generated scenario from Test Procedure Interactive Execution. Here is the result. In green, the elements that have been fully covered. In yellow, the partially covered. And you could also have in red the ones not covered at all. In summary, you've seen how you can perform software closed-loop testing with a virtualized environment. This enables you to debug, tune, and test your software and solve issues far before integration in its real environment. Go check more information on ANSYS Simplorer and ANSYS SCADE Test. Thank you.